Okay, here we go. Going to try now apply some of that trig that we've learned. This is the most useful part. This is the whole point, right triangle trig. So if we know an angle, theta, we know one of the sides. I went A, B, C because it's a right triangle. Most famous of all theorems from mathematics, a squared plus b squared equals c squared. You get the old Pythagorean theorem. That's going to be in here. Um, if you know an angle and one of the sides, then you can figure out the lengths of the other two sides. So you give me one of these. So, for example, if I know the hypotenuse, if I know C, what do I know? All right, and I wanted to find out either A or B. Let's say I wanted to find out A. How can I relate the angle in this A, side A, and C? So remember what A is. A is opposite. Here's the angle over here, and A is opposite that angle. It doesn't actually touch the same vertex where the angle is. A is the side that doesn't touch the vertex side where the vertex is. It's opposite. All right. What's B? B is the adjacent. It's right next door. It does. The B is the one that shares the vertex with the angle, and C is the hypotenuse, the longest side in the triangle. All right. So what do I know with A and C? Opposite hypotenuse. Opposite hypotenuse. That's sine. Sine. SOHCAHTOA. So sine is opposite over hypotenuse. There you go. A over C. So if I know C, I'm looking for A. So I have to get A by itself. So the only thing I have to do is multiply both sides by C. C and C over here. And then those two C's cancel. And you're going to get C times sine of theta equals A. So if I wanted to find out what that side is, I just multiply the hypotenuse by the sine of this angle. All right. Let's see. To find out B. Now I have to see what do we have to do for B? B is adjacent hypotenuse. That's cosine COHCAHTOA. So there's cosine B over C, and we're looking for B. So again, I just have to multiply both sides by the C, and I get B is equal to C times cosine theta. So that one's easy. When you know the hypotenuse is relatively easy. All right. What about if you know, the opposite? Now, if I know the side opposite, and I wanted to find out B, I don't know which one do I do first. I think I do the C. Yeah, because opposite and hypotenuse, if I do C first, opposite and hypotenuse is sine again. Is that what I do? Yes. And so now we want to find out. So now this time we're trying to find C. So if I multiply both sides by C, that's nice. It gets out of the denominator. Now I got the sine is still over on this side. So to get the sine back over here, I would have to divide. And I'm going to get, the C is going to be left over here, and sine is going to come down here in the denominator. You get C equals A over sine theta. So if I know this side, to find out the hypotenuse, I just divide that number by the sine of the angle. All right, and then the B, let's see. Now I get to that one it's always the last one. Opposite adjacent. Opposite and adjacent, TOA. Tangent gets hard, but look, please see what tangent is. Opposite. Rise. What's the B? That's the run. That's the horizontal. Rise over run. It's a slope. Tangent has to do with slope. Tangent equals A over B, so I know A. I want to find out B. So let's see. B goes, I multiply both sides. But B, get the B on this side. And then there's only A on this side, but I don't want to know A. That's the thing I do know. So to get B, I have to divide both sides by tangent. And that gives me B equals A tangent theta. Okay. And we got one more side to go. So now if I know the adjacent, and I know I do tangent last. I think it's unconscious bias. But anyways, TOA, it's coming at the end. We got B, so I got the adjacent. So I can do hypotenuse or the opposite. I probably went with the hypotenuse first, did I? I did. Because adjacent in the hypotenuse is, adjacent, that's COHCAHTOA. So there, I got cosine equals B over C. All right, I know B. I want to find C. So again, we're doing that whole thing, multiply both sides by C and then divide by the cosine. And so you get C is equal to B divided by cosine of the angle. So if I know the side, because sine and cosine are always a number when you're in the first quadrant. Let's keep it in the first quadrant. It's always a number between 0 and 1. And all right triangles are in the first quadrant, so that's a nice place to say. And C is always the longest side, so I'm going to be dividing this number by a number less than 1, which is going to make it bigger. I got to make it bigger. Don't forget, sine and cosine are always a number between 0 and 1 first quadrant. It's always a number between -1 and 1. All right, and the last side. All right, so now I want to do A. That's a tangent again. I know B. So I want to get A. So this time all I have to do is multiply both sides by B, boop, boop, and A will be all by itself, and you get B times tangent theta. And one more? Or did we do them all? No. All right, so here we go. Oh, these are where you use them, and they're going to be in word problems. You have a 12-foot ramp that is used on a loading dock, a 12-foot long ramp. So how does that go? Oh, do I have a picture? Oh, look, I have a picture. That's going to be the 12 is going to be the hypotenuse. How high is the loading dock? Oh, that's over here. And the angle of inclination. That means how much does it come up off the ground. So this is the angle of inclination. So a 12-foot ramp that is used on a loading dock has an angle of inclination of 15 degrees. How high is the loading dock? How far from the loading dock is the base of the ramp? Oh, that's going to be B. Yeah, so A ends up being 12 times the sine of 15. Oh, I had it open. Do I still have it open? I do. This is a calculator. It's the old one, but you have this on your computer if you'd want. But I wanted to go 12. So the one thing on this computer, if you're going to see 15 degrees, you need to change your mode. Please don't do this when you're in my calculus class. You never want to touch this button when you're in my calculus class. It defaults to radian, but most likely, if you haven't changed it, it's probably a radians. But if you're going to be doing stuff with the degrees, you need to come it down here. Come on, down, and then over, and then you hit enter, and then you say second, quit, and then you're back there. So now I go 12 sine. See, these are all these buttons on your calculator. You're like, what are those for? It's trigonometry. 12 sine 15, 3.105, which I rounded to 3.1. This gives you a more accurate answer, although it's not exact. And then, all right, to find B, what are you going to do? Oh, that's again, because the hypotenuse. The hypotenuse is the easy one. You just multiply by the number, and 12 times cosine of 15, I approximate is 11.6. Let's see, what is it a little bit more precisely? 12 cosine 15 into 11.59, which I rounded to 11.6. Okay. Is that it, or is there one more? I think there might be one more. Oh, there is one more. Oh, it's the SAT problem. Okay. Do a couple more of these later. In the figure above, so this is where you'll see this. You don't really need to. I'm going to say right now, as a geometry teacher as well, you can do this all with similar triangles, but it has to do with trigonometry. But please see, I'm not going to make you do the proof, but those two are vertical angles, and that's a right angle, and these are parallel, which makes that a right angle. And then you could say that they are two similar triangles, because angle similarity theorem, sure. And now we can set up proportions between the blue, I'm going to call that blue, and the green triangle. That means the ratio of their sides. And this is what trigonometry is all about. It's about the ratio of the sides. So angle, we find that this angle up here, I'm going to call it angle A, is congruent to angle C. Those two angles are the same. The length of the sides aren't the same, but the angles are the same. That's what it means to be similar. So that means the ratio of the sides are the same. So it means that the short leg to the long leg is the same as the short leg to the long leg. And then we can figure it out using Pythagorean theorem. And then you could just use Pythagorean theorem to find this side, because we're going to have to do Pythagorean theorem right off the bat. Anytime you're doing an SAT problem, you're going to be doing Pythagorean theorem. So, Oh, what is the Pythagorean theorem you say? You know it. A squared plus B squared equals C squared. So let's see. 5 squared plus 12 squared equals C squared. 25 plus 144 equals C squared. Therefore, 169 equals C squared. And I hope you know your perfect squares, because that is one. It's 13. So now we know that this side's 13. And then we could just use proportions to find this side, but we're going to use trig instead, because it's the same idea. They're related. So, all right. So you're telling me that sine of this angle, A, is the same as the sine of this angle, C. Fine. What is the sine? We now know that all three sides in this triangle, so we can figure out the sine of angle A. Opposite, that's the 5 side, DE over here, and the hypotenuse, AE, which we just figured out was 13. So the sine of A, please be that's what, oh, look, sine of A is equal to 5 over 13, good, equals sine of C. So yes, down here. Okay, now what does that mean? I now know this side is 1. So let's see. I know the adjacent. Hold on, we're going to go back a couple of slides here. So now I know the sine of this angle, and I know the opposite side. Sine of the angle and the opposite side. Sine of the angle and the opposite side. So, the hypotenuse is just A divided by sine of theta. Fine. That. Oop. Yep, there it is. So that means that EC equals 1 divided by sine 1, that side, divided by sine of C, equals the reciprocal. 1 over something is the reciprocal. So that means, what's the reciprocal of 5 over 13? It was 13 over 5, which is about, it is 2.6. 5 is nice. 5 is because we have 5 fingers and we have a base 10 system. And don't get me started. AC, let's do a little geometry. This length, because that's what they're asking us for, is AE plus EC. Yeah. That's geometry. We know this side's 13. We know that side's 2.6. Total is 15.6. And I do believe that's it.